Good evening everyone. So we are in the 6th tutorial of the Econometrics tutorial series. In your last two lectures, students, you have learned about the time series Econometrics. So today's tutorial is based on what you have learned in your lectures. So if we move to the first question of the today's tutorial, it is asked to explain what is mean by time series data and provide three examples for that. So in the section they are asking what is mean by this time series data and provide three examples for that. Simply we can say time series data are the data which are collected in equal time period like annually or monthly. For example, simply time series data are the data which are collected in equal time period like annually or monthly, right? So, and what is the basic principle used in this time series data? It is the future is reflected by the past, or based on the past results that we have, we can predict the future. That is the basic principle or the basic idea in this time series data, right, students? So, and the question they are asking to provide three examples for time series data. Simply you can say annual GDP, monthly inflation, or annual interest rate. Likewise you can say different examples for time series data which are collected in equal time period like GDP, right? If I go to the answer for the tutorial, you can see that the time series data are the data or the values that are collected in equal time periods, right? And there is another definition. It says that time series data are the data that collected for a variable from different equal time intervals, right? And then it says that time series data allowed for the analysis of trend cycles or forecasting over time. So based on the time series data that we have, we can forecast what will happen in the future. And there are three examples given in the answer. That one is annual GDP, quarterly inflation, and monthly interest rate. Likewise, you can identify any examples like this. So if we move to the second question, in the second question they are asking explain what is mean by the stationarity in time series data and why it is important, and mention three tests that you can use to check the stationarity. So in this question they are asking three things. First, what is mean by stationarity in time series data, why it is important, how you can check the stationarity, right? If we move to your session 7, you have learned about several concepts related to this time series econometrics. First concept that you have learned is stochastic process. Simply, what is mean by this stochastic process? It says that a random or stochastic process is a collection of random variables ordered in time. Simply, we can say stochastic process is a process that collected data related to a variables, and the those data values of those data are unknown. Values of those data are unknown until we observe it, right? In the stochastic process, we are collecting the values related to some variables, and the stochastic process mean the values that we are collecting for those variables are unknown until we observe it, right? So that is what we call stochastic process. So if we move to the second step, it says about stationary stochastic process. So second concept is about stationary stochastic process. So it says that a stochastic process, that means this kind of a stochastic process is said to be stationary. This kind of a stochastic process can be said as stationary if it is mean and the variance are constant over the time. If the mean and the variance of this kind of a stochastic process are constant over the time, we can say it is stationary, right? So that means in this stochastic process we are collecting values for different variables, right student? So the mean and the variance of these values are constant over the time. We can say this stochastic process is a stationary, right? And there is another concept that is called as purely random process or white noise process. So in this kind of a process, what happen is, in a stationary process the mean and the variance are constant, right? But in a purely random process or the white noise process, the mean becomes 0 and the variance is constant. Only the variance is constant and the mean becomes 0. So if I explain the same thing in Sinhala, stochastic process එකක් කියවලමයි අපි සරල මොකක් හරි variable එකක් ගත්තම ඒ variable එකට අදාළ data එහෙම නැත්නම් අපි values collect කරනවා. එන්න මේ collect කරන values අපි ඒව observe කරනකම් අපි දැනන් ඉන්නේ නැහැ. අන්න ඒ විදිහේ process එකකට තමයි අපි කියන්නේ stochastic process එකක්. එහෙම නැත්නම් මෙන්න මේ values වලට එන්න පුළුවන් අගේ random අගයක්. ඒ කියන්නේ අපි මේක observe කරනකම් අපි දන්නේ නැහැ මේකේ අගේ කොහොම වේද කියලා. එතකොට මෙන්න මේ විදිහේ process එකක collect කරනවානේ අපි values වගේක්. එහෙම නැත්නම් variable වලට values collect කරනවානේ. මෙන්න මේ collect කරන values වල mean එක සහ variance එක කියන දෙක ගත්තම මෙන්න මේ mean එකයි variance එකයි කියන දෙක over the time constantly තියෙනවා නම් අන්න ඒ වගේ වෙලාවක තියෙන process එකකට අපි කියනවා stationary කියලා. හරිද? එතකොට තව concept එකක් ඔයගොල්ලෝ මෙතන කතා කරා purely random process සහ white noise process කියන එක. ඒකෙදි වෙන්නේ මෙන්න මේ mean එක සහ variance එක මෙන්න මේ values වලට අදාළව ඔයගොල්ලෝ collect කරන mean එක සහ variance එක කියන දෙක ගත්තාම mean එක කියන එක 0 වෙනවා. හැබැයි constant කියන එක variance එක කියන එක constant ව තියෙනවා. හරිද? So we have talked about what is mean by stationary in time series data, right? So the first part of that question is done. Now we are moving to the second part of that same question. So in the second part of that question it is asked why this stationarity concept in the time series data is important, right? So you know that by using the time series data we can forecast what will be the results in future. Simply, let's say you have a last 12 month data related to a sales in a particular product, so you can predict the sales in the next month. What will be the sales in the next month based on the data that you have, right? So likewise you can do some kind of a forecasting using time series data. But let's say there are some huge variances or some kind of a shock happened in the last 12 months, so you can't predict what will be the sales in the next month accurately, right? Because of some kind of a shock or some kind of a significant change happened in the company or significant change happened in the production process, there has been some significant changes in their sales or the production, right? So because of that you can't exactly, or in a forecasting we can't exactly say what will be happen, but your accuracy will be lower because of that some kind of changes happened in last 12 months. I mean significant changes happened in the last 12 months. So in the stationary concept what we say is, when we say the time series data are stationary, we said that the values or these time series data's mean and the variance are constant, right? When we said it is the time series data are stationary, their mean and the variance are constant. So that when we said the mean and the variance are constant, in that kind of a data set there are no huge fluctuations or huge changes like I said. So when there is no such kind of a huge changes or huge variances, we can forecast more accurately than previous, right? When the mean and the variance are constant, that means we can forecast more accurately, right? So students, if we move to your lecture slide, Why a stationary time series is so important? Because if a time series is non-stationary, let's say the time series is non-stationary, we can study its behavior only for the time period under the consideration. So let's say the time series data that you have is non-stationary. That means there are huge changes, or the mean and the variance are not constant. So you can't accurately predict the future, or you can't accurately forecast. So in that kind of a situation, we can only study its behavior only for the time period under consideration. එතකොට මෙහෙම තියෙන වෙලාවක මේ විදිහින් non stationary වෙලාවක අපිට පුළුවන් ඒ අපි ස්ටඩි එක කරන පීරියඩ් එකේ තියෙන විස්තර ගැන තවදුරටත් අධ්‍යයනය කරන්න විතරයි. ඒ හැර ඒ තියෙන විස්තර පාවිච්චි කරලා තවත් ඉස්සරහට අපිට ප්‍රෙඩික්ට් කරන්න හැකියාවක් නැහැ. මොකද එහෙම අපි ප්‍රෙඩික්ට් කරත් ඒකේ ඇකියුරසි එක ගොඩක් අඩුයි. මොකද ඒ තියෙන ඩේටා සෙට් එක non stationary හින්දා. එහෙම නැත්නම් ඒ ඩේටා සෙට් එකදී ගොඩාක් ලොකු චේන්ජස් වෙලා තියෙන හින්දා. එතකොට මෙන්න මේ හින්දා stationarity කියන එක time series data වල තියෙන ඕන ඉතා වැදගත් ගුණාංගයක්. So in the next part of question it is asked, identify 3 tests that can be used to check the stationary. So in your lecture you have learned about these tests. One thing is you can use scatter diagram to identify whether the mean and the variance are constant, and you can also use autocorrelation function, and the easiest one that you can use unit root test. By using any of these 3 tests, you can identify whether the data set is stationary or not, right? So students, with that we have done with the second question. Now we can move to the third question. In the third question it says that using the tutorial 6 dataset 1, answer the following question. So in the first question they say, identify whether the variables in the dataset are stationary using the following method. So there is some kind of a dataset and there are some variables included in that dataset, and they ask to identify whether the all variables in the dataset are stationary, and you have to use all of these 3 methods, right? And in the part B they ask, if the stationary assumption is not valid, transform the variables by first differencing and recheck for the stationary using the following method. So they ask, identify whether the variables are stationary at the level data by using these 3 methods. If the data are not stationary at the level data, try to identify whether those data become stationary at their first difference using all of these 3 methods, right? So if we move to your data set, this is your data set tutorial 6 dataset 1. So in this data set there are data from year 1980 to 2021, and there are variables like GDP, inflation, interest rate, oil price and exchange rate. So in the question they ask to identify whether all of these variables are stationary or not at their level data, and you have to identify it by 3 methods, by using a scatter diagram, autocorrelation function and unit root test. And if any of those variables are not stationary at level data, you have to check whether those data become stationary at their first difference, right? So to do that you have to open your EViews software. So in the EViews software you can go to file, then click import, and then click import from file. From that you can select the data set that you have, that is tutorial 6 dataset 1, and since we in the data set this is in the sheet 1, so you don't have to change the predefined range. Then you have to select sheet 1, then click finish, right? And select no for this. Then your data set will be imported to the EViews software. So students, in our data set the first variable is the exchange rate. So now the first method we are going to use is, by using a scatter diagram we try to identify whether this exchange rate is stationary or not, right? So to do that, there are mainly two ways that you can use in EViews. First way is you can double click on the exchange rate. You can double click on the exchange rate. So when you double click the exchange rate, it should pop up the window like this. In this window, you can go to view, then click graph, then the graph type is basic type and it is a line and symbol graph, then press OK. So you can come up with this kind of a graph. Or there is another way that you can do, then that is you can go to quick, then click graph and select the variable that you want, then press OK and press OK again. So it is give the same result, but the advantage of using the graph by going to this quick is, in the first method I have shown to you, you can't use differencing, but when you going to generate a graph by going to quick and graph, then you can in here you can say D and the variable name. So it will generate the graph by using the first difference, right? So that is the benefit of using by generating a graph by going to quick, right? So this is the initial graph that we have drawn. So in this graph we can see that the mean is around something like this. That means the mean might be constant in this kind of a situation. But what about the variance? The variance is not constant, right? The variance can be higher like this, and sometimes it's become very there are high gaps and high lows, right? That means the variance is not constant in this kind of a situation. So we can say exchange rate is not stationary at its level data by using scatter diagram. As a result, we get from a scatter diagram the mean is constant but the variance is not constant. Because of that, we can say exchange rate is not stationary at level data, right? So I will take a screenshot of this and go to my Excel and then create another sheet. Then my variable is exchange rate, and I can type here exchange rate is not stationary at level data. So this is for your record. You can type and save your workings like screenshot like this, so you can easily understand what you have done in previously. Since we say this is not significant, now we can go to EViews and try to estimate the exchange rate at their first difference and try to identify whether it is stationary at first difference or not, right? To do that, you have to go to quick, then graph, and in here you have to select the variable, then press D and brackets like this and then press OK. So you have to select the graph type and then specify line and symbol, then press OK. So you will get the scatter diagram for first difference exchange rate. So in here you can see that mean is 0, mean is around 0, or we can see that mean is around 0, right? And the variance is in here the variance are constant, but there are some huge changes, but most of the time variance is like constant, right? So variance is like constant. So if we want, we can assume that the mean and the variance are constant at their first difference, right? So I will take a screenshot of this and I'm going to put it in my Excel, right? So if we move to our question, we have our first variable we have used is exchange rate. For exchange rate, we use the scatter diagram and we firstly identified that it is not stationary at level data. Then we have transform it to first difference and try to identify whether it will become stationary using scatter diagram, right? And we said that it will become stationary, right? Now we are going to do the same. That means for the exchange rate, now we are going to check whether it will become stationary at level data using autocorrelation function. So I will go to EViews. I will remove these two graphs. So to run the autocorrelation function, what you can do is you can double click on the exchange rate. So when you double click the exchange rate, you will come to this spreadsheet or the results of your data set. Then you can go to view, then press correlogram and select the level data. Since we are not going to take the first difference first, we are going to check the stationary at level data. So because of that, I select the level and then press OK. So here you have the autocorrelation function, right? So since our second method is by using the autocorrelation function, we are going to identify whether the variable is stationary or not, right? Now the variable we are using is the exchange rate. Now we have the autocorrelation function for the exchange rate. So there are two conditions in this situation. There are two criteria to be satisfied, that if both of those two criteria are satisfied, we can say that the variables are stationary. For those two criteria are, one thing is the values or the data in here should not have any kind of a systematic pattern. These data in here, this data point should not have any kind of a systematic pattern. So in this autocorrelation function, we can't see any systematic pattern, right? We can't see any systematic pattern. And also the next condition is these result can't go beyond this significance level, or these values should be within these two confidence level. The values, all these lag values should be within these two confidence level. So we can see that there is no any systematic pattern, and also all the values are here within the confidence level. එතකොට අපි autocorrelation function එක පාවිච්චි කරලා මේක ස්ටේෂනරිද නැද්ද කියලා චෙක් කරගන්න යද්දී අපි කියන කන්ඩිෂන් දෙකක් හිට වෙන්න ඕනේ කියලා. පළවෙනි කන්ඩිෂන් එක තමයි මෙන්න මේ තියෙන data set ටික කිසිම systematic pattern එකක් විදියට තියෙන්න බෑ. ඒක just random විදියට තමයි තියෙන්න ඕනේ. එතකොට මේක වෙලාවෙ අපිට බලා ගන්න පුළුවන් මේකේ කිසිම systematic process එකක් නැහැ. මේ වෙලාවෙ වැඩි, ආයෙ මේ වෙලාවෙ ගොඩක් අඩු වෙලා තියෙනවා, ආයෙ වැඩි වෙලා තියෙනවා. මෙතන කිසිම systematic pattern එකක් අපිට දැක ගන්න නැහැ. හරිද? එතකොට මේ වෙලාවේ තියෙන random pattern එකක්. අනිත් දේ තමයි මෙන්න මේ values ටික ගත්තාම මේ values මෙන්න මේ දෙපැත්තේ තියෙන කඩයිලි දෙක. එහෙම නැත්නම් අපි කියනවා confidence interval කියලා. මෙන්න මේ confidence interval දෙක අතරේ තියෙන්න ඕන. අන්න එහෙම තියෙනවා නම් අපිට කියන්න පුළුවන් මෙන්න මේ condition දෙකම satisfy වෙනවා නම් අපිට කියන්න පුළුවන් මේක stationary කියලා. So we have run the autocorrelation function for the exchange rate at their level data, and we can see that since both of the conditions are satisfied, we can say that the exchange rate become stationary at its level data by using autocorrelation function. So I will take a screenshot of this and go to my Excel, and I will paste it here, and I can say that exchange rate become stationary at its level data according to the autocorrelation function, right? So in the previously we have used the scatter diagram, and in the scatter diagram the exchange rate was not stationary at level data, but we said that it will become stationary at first difference as per the scatter diagram, right? And now we are in the second method. The second method is the autocorrelation function. In the autocorrelation function, we can see that at the level data, the exchange rate becomes stationary, right? So we don't need to run the autocorrelation function at the first difference because the data becomes stationary at its level data, right? So the third method they asked to conduct is conduct the unit root test. By conducting a unit root test, you have to easily identify whether the data or the variable is stationary or not. So to do that, you can go to your EViews, then here you can go to your spreadsheet first, then click here view, then click unit root test, standard unit root test. Here select the test type as augmented Fuller test. Then we are testing at the level data, and the test equation consists with trend and intercept. Then press OK, right? So this is the results of the unit root test. So there is a null hypothesis. The null hypothesis is the exchange rate has a unit root. That means the null hypothesis is variable is not stationary, right? And that means our alternative hypothesis is variable is stationary, right? So I will take a screenshot of this and go to my Excel. So I will paste my screenshot here. So what is your H naught? Your H naught is variable is not stationary. Variable is not stationary. That is what mean by this exchange rate has a unit root. Then what is your H1 or alternative hypothesis? Your alternative hypothesis is variable is stationary, right? So our general condition for accepting the null hypothesis or the alternative hypothesis, the decision we are taking on based on the probability value. So our decision rule is reject H naught if p-value is less than 0.05. So we are going to reject the H naught. That means we are going to reject our null hypothesis if the probability value is less than 0.05. In this situation, we can see the probability value of the ADF test is less than 0.05. That means we can reject the H naught and accept the H1 of alternative hypothesis. That means according to unit root test, the exchange rate is stationary at its level data, right? එතකොට අපිට මේ ස්ටේෂනරිද නැද්ද කියලා පාවිච්චි කරන්න මොකක් හරි දෙයක් චෙක් කරගන්න පාවිච්චි කරන්න පුළුවන් වඩාත් ලේසිම දෙයක් තමයි යුනිට් රූට් ටෙස්ට් එක කියන එක. මේක ස්ටැටිස්ටිකල් ටෙස්ට් එකක්. මේකේ හයිපොතසිස් පාවිච්චි කරලා තමයි අපි ඩිසිෂන් ගන්න. එතකොට මේක දීලා තියෙනවා null hypothesis එක විදිහට exchange rate has a unit root. එහෙම නැත්නම් මේකේ අදහස් තමයි exchange rate එක එහෙම නැත්නම් variable එක stationary නෑ කියන එක. H1 එක තමයි අපේ null hypothesis එක වෙන්නේ. ඊට පස්සේ වාගේ alternative hypothesis එක ගත්තම alternative hypothesis එක වෙන්නේ variable එක stationary කියන එක. null hypothesis එක කියවෙන්නේ variable එක stationary නැහැ කියන එක නම් alternative hypothesis එකෙන් කියවෙන්නේ variable එක stationary කියන එක. හරිද? එතකොට ඔයාගේ decision rule එක තමයි reject the H naught if p value is less than 0.05. මෙන්න මේ probability value එක ගත්තම මෙන්න මේ probability value එකේ අගය 0.05 වලට වඩා අඩුයි නම් අපි null hypothesis එක එහෙම නැත්නම් H naught reject කරනවා. එතකොට මේ වෙලාවේ probability value එක ගත්තම මේක 0.05 වලට වඩා අඩුයි. ඒ කියන්නේ අපි null hypothesis එක වෙච්ච H naught reject කරලා H1 කියන එක නාම accept කරනවා. ඒ කියන්නේ H1 වල කියවෙන්නේ variable ගත්තම මේ variable stationary කියලා. එහෙමනම් මෙන්න මේ unit root test එකට අනුව මෙන්න මේ exchange rate කියන variable එක ගත්තම ඒක stationary වෙනවා එයාගේ level data වලදීම. හරිද? So students, there are another few variables like GDP, inflation, interest rate, oil price. Likewise, there are several variables. Since we have a limited time, I'm not going to discuss each and every variable, right? You can try to do everything by yourself because all are same, like we have similar to what we have done with the exchange rate. For your knowledge, I'm going to show there is a easy way that you can check the stationary of all of these variable by using the unit root test, right? So to do that, what you have to do is you have to select the all the variables, then right click and open as a group, right? Then all the data will be open like this. Then what you have to do is you can go to view, then click unit root test, cross-sectionally independent, and here test type is individual root Fisher ADF. Then we are firstly checking at the level data and individual intercept and trend, then press OK. So you will come up with the answer like this. In here there is all your variables and their probability value. You can see that the GDP is not stationary at level data, but all other variables become stationary at level data. So if I check that by here, we can double click here, view, go to unit root test, standard unit root test at level data, trend and intercept. So you will get a similar result like this. GDP in here also not stationary at level data. Here also you can see that it is not stationary at level data, but all other variables except GDP become stationary at it level data, right? So you can try to do all other variables whether they become stationary at level data or first difference by using the scatter diagram and autocorrelation function later, right? So now we are moving to the fourth question. So in the fourth question it says that using the same data set from the question 3, answer the following question. So in the first question they are asking, explain what is an autoregressive model mean. Explain what is an autoregressive model mean. So you have learned this in your lecture. If we move to your lecture slide, the autoregressive model or AR model, simply it's a what this AR model says is the present value of a variable. If we take a present value of a particular variable, it is a function of its previous value, or we can say present value is reflected by its previous value, or in other words the present value of a variable is a function of its previous value. So if I write it, the present value of a variable is a function of its previous value, So the present value of a particular variable is a function of its previous values. That means කිව්වේ සරලවම මොකක් හරි වේරියබල් එකක වර්තමානකය ගත්තාම මෙන්න මේ වර්තමානකයේ හැදිලා තියෙන්නේ ඒකේ අතීතයේ තිබ්බ වැලියුස් තියෙනවානේ. මෙන්න මේ අතීතයේ තිබ්බ වැලියුස් වල එකතු. එහෙම නැත්නම් මෙන්න මේ අතීතයේ තිබ්බ වැලියුස් මතින් තමයි මෙන්න මේ ප්‍රසන්ට් වැලියු එක හැදිලා තියෙන්නේ. අන්න ඒක තමයි සරලව මේ ඔටෝ රෙග්‍රෙසිව් මොඩල් එක අදහස වෙන්නේ. හරිද? One of the example you can give for this is the sales revenue in 2024 is determined by the sales achieved in 2023. 2023. That means based on the sales that we have achieved in the 2023, the sales revenue in the 2024 is determined. Based on the sales revenue that we have achieved in the 2023, our sales revenue in the 2024 is determined. That is the idea of the autoregressive model. In the autoregressive model, we said that the present value of a variable is a function of its previous value. So the current year sales revenue, that means the sales revenue of the 2024 is determined by the sales revenue achieved in the previous year or the year achieved in 2023, right? So you can write the equation for that, for the sales revenue in 2024 like this. YT, or this represents the sales revenue. It is a function of beta naught plus beta 1 into y t minus 1 plus your error term, right? So this kind of a equation, we said that this is a AR1 model, because to determine the current year sales, only a 1 year or only one previous year value was taken. So because of that, we said this is an AR1 model. If I simply explain the same thing again, this is the sales revenue in 2024. We said that the sales revenue in 2024 is determined by based on the sales revenue in 2023, right? So that means to determine the sales revenue in 2024, the 2023 sales revenue have some kind of impact. Since there are only an impact from 2023 we have identified here, we said that there is only one AR term. Let's say there are two variables, that means for the 2024 sales there are impact from 2023 and also 2022. So your equation will be like YT into beta naught plus B1 into YT minus 1 plus beta 2 into YT minus 2 plus your error term, right? So this type of AR model we call AR2 model, because there are two AR terms or 2 year factors have determined the current year sales. That means the present value of the sales or the present sales is determined by both previous year sales and the value before 2 years. That means the 2024 sales is determined by 2023 sales and 2022 sales as well, right? එතකොට මෙන්න මේ AR මොඩල් එක ගත්තා. මේ AR මොඩල් එකේ අපි කියන්නේ 2024 උදාහරණයක් මම මේ කිව්වොත් එහෙම සේල් 2024 සේල්ස් රෙවෙනියු එක ගත්තම ඒක ඩිටර්මයින් වෙන්නේ 2023 සේල්ස් වලින් කියලා අපි කියනවා. එතකොට 2024 සේල්ස් කියන එක ෆන්ක්ෂන් එකක් විදිහට අපි ගත්තොත් එහෙම ඒක හැදෙන්නේ 2023 සේල්ස් වලින්. හරිද? එතකොට අපි කිව්වා AR model එක කියන්නේ present value of a variable is a function of its previous value. present මොකක් හරි variable එක present value එක කියලා කියන්නේ ඒකේ previous value වල function එකක්. එතකොට මේක තමයි කියන function එක. එතකොට 2024 sale එක තීරණය වෙන්න 2023 sale එක විතරයි බලපෑවේ. ඒ කියන්නේ එක AR term එකයි මෙතන බලපෑවේ. ඒ කියන්නේ මෙන්න මේ function එක ගත්තා. මේ function එක ඇතුලේ තියෙන්නේ එක variable එකයි. ඒකින්ද අපි මේකට කියනවා AR1 model එකක් කියලා. ඒතර දෙවෙනි උදාහරණය ගත්තම 2024 sale එක තීරණය වෙන්න 2023 sale එක කොච්චරද කියන එක සහ 2022 sale එක කොච්චරද කියන එක කියන දෙකම බලපෑවා. ඒකින්ද මේ අවස්ථාවේ variable දෙකක් බලපාපු හින්දා මේකට කියනවා AR2 ආකාරයේ model එකක් කියලා. හරිද? So if I move to your tutorial, the first question is asking explain what is an autoregressive model. So we have discussed what is mean by autoregressive model. So in the part B they ask use GDP as the variable for the AR model and identify the level at which GDP becomes stationary. Previously I have only checked the stationary for the exchange rate and I have not checked the stationary for any other variable. So first of all I need to check about the GDP and identify at what level this GDP become stationary, right? So to do that I will go to EViews, close all of these things and go to GDP and view unit root test, standard unit root test, ADF test. At level data first I'm going to check and I'm select both trend and the intercept, then press OK. So we can see that it is not significant at the level data, right? Or it is not stationary at the level data. So we have to rerun it in the in first difference. So I'm going to view unit root test, standard unit root test, and here I'm now selecting, instead of level data I'm selecting the first difference, right? Then press OK. So in here we can see that now the probability value is less than 0.05. that means we are rejecting the null hypothesis. The null hypothesis says that DGDP has a unit root, that means the variable is not stationary. Since we are now rejecting the null hypothesis, we can see that this GDP is become stationary at its first difference, right? එතකොට මෙන්න මේ GDP කියන එක ගත්තාම අපි GDP එක ස්ටේෂනරි වෙනවද කියලා බලුවා යුනිට් රූට් ටෙස්ට් එක පාවිච්චි කරලා ෆස්ට් ටයිම්. එතකොට ලෙවල් ඩේටා වලදී මේක ස්ටේෂනරි වෙන්නේ නැහැ කියලා අපි දැනගත්තා. ඒකින්ද අපි මොකද කරේ? ආයේ අපි මේක යුනිට් රූට් ටෙස්ට් එක කරා. හැබැයි මේ වෙලාවේ මේක අපි කරේ ෆස්ට් ඩිෆරන්ස් එකට. එතකොට ෆස්ට් ඩිෆරන්ස් එකට කරාට පස්සේ අපිට පුළුවන් මේකේ probability value එක 0.05 වලට වඩා අඩුයි. ඒ කියන්නේ අපි මේ null hypothesis එක reject කරනවා කියන එක. ඒ කියන්නේ මෙන්න මේ වෙලාවේ මේ GDP කියන එක stationary වෙනවා එයාගේ first difference එකේදී. හරිද? So now we have identified the answer for the part B. So now we know that GDP become stationary at its first difference. So the GDP become stationary at its first difference. Become stationary at first difference. Right. So now we are moving to the part C. So in the part C, it asks determine the appropriate order of the AR model for GDP using the partial autocorrelation function. So in your lecture you have learned how to identify the number of AR terms in an AR model using a partial autocorrelation function, right? So now we are going to identify how many number of AR terms included in the model using the partial autocorrelation function. So to do that I'm going to EViews. Then since we have already selected DGDP GDP variable, I'm going to go here, view. Here I will go to view, then select correlogram, and since we know that the data becomes stationary at first difference, instead of level data I will select first difference, then press OK. So now you have the autocorrelation function related data and the partial autocorrelation function related data, right? So you have the results of the partial autocorrelation here, and to determine number of AR terms, what you have to do is you have to identify how many variables or how many results are go beyond the significance level. How many results are go beyond this to significant level. So in here there is only one variable which go beyond this significant level, right? So based on that we can identify this as there are only AR1 model. This is an AR1 model, right? That means there are only one AR term in this model, right? එතකොට අපි AR model එක ගත්තම AR model එකේ තියෙන number of AR term. එහෙම නැත්නම් කලින් අවුරුදු වල දැන් ඇත්තට මේ AR model එක කතා කරන්නේ මේ අවුරුද්දේ value එක ගත්තම මේ අවුරුද්දේ value එක තීරණය වෙන්න කලින් මොන අවුරුදු වල value වලින්ද impact එකක් තියෙන්නේ කියන එක බලන එකනේ. එතකොට ඒක බලද්දී අපි AR term කීයක් තියෙනවද? එහෙම නැත්නම් පහුගිය මොන අවුරුදු වල තියෙන්නේ impact එක මේ අවුරුදු sales වලට කියලා බලන්න අපි පාවිච්චි කරන්නේ මෙන්න මේ partial correlation එක ගත්තම මෙන්න මේකේ significant level එකට වඩා එහා ගිය values තියෙනවනම් අන්න ඒ years වලින් තමයි අපි identify කරගන්නේ impact එකක් තියෙනවා කියලා මෙන්න මේ present year එකට. එතකොට මේ අවස්ථාවේ ගත්තම අපිට මෙන්න මේ first level එක එහෙම නැත්නම් පළවෙනි අවස්ථාවේ තියෙන variable එකේ විතරයි අපිට බලා ගන්න පුළුවන් significant impact එකක් තියෙනවා කියන එක. හරිද? එතන අපිට කියන්න පුළුවන් මේ වෙලාවේ මේකේ තියෙන AR term ගාන එකයි කියන එක. හරිද? So now we are moving to our tutorial. So in the part C, it is asked to determine the appropriate order for AR model using the partial autocorrelation function. So using the partial autocorrelation function, now we know that the appropriate order of the AR model is AR model 1, right? So in the part D, it is asked to estimate the AR model for GDP and interpret the results of your output, right? So now we have to run the AR model for GDP and then analyze or interpret the results in the estimated window. So to do that, I will go to my EViews. I will close this sheet. Then I will first go to quick. Then you can click estimate equation. And firstly I will type DGNE. So DGNE means we know that, sorry, DGDP, that means we know that GDP becomes stationary at its first difference. So because of that I will type DGDP. Once you type the GDP, the full name will pop up here. Then you can double click it from here, then close bracket, then I said C and AR1 within bracket 1, right? So in EViews, not like Stata, you have to identify what is your dependent variable, what is your intercept or the C value. Then you have to identify, after C you have to type your independent variables, right? So in this equation, DGDP is the first difference of the GDP. So the first difference of the GDP is a function of intercept plus AR1 mean the previous year first value. That means the DGDP is depend on the AR1, right? So I will press OK. So I can come up with the results for my AR model. So in here you can see that the AR variable is significant since the T statistic probability value is less than 0.05. I can say that the variable AR or the AR1 model is significant, and we can see that our R square and adjusted R square is around 23 to 25%, right? And what about the overall significance of the model? When we look at the probability value of F statistic, you can see that it is also less than 0.05. That means overall model is significant, right? So with that we have completed the fourth question as well. Now we are moving to the fifth question. Before moving to the fifth question, if I briefly explain what we have done in this AR model, Simply a AR model say the present value of a variable is a function of its previous value. එතකොට මේ AR model එක ගත්තම මේ AR model එකේ සරලව කියන්නේ මොකක් හරි variable එක වර්තමාන අගය ගත්තම ඒ variable එකේ වර්තමාන අගය කියන්නේ කලින් අවුරුදු වල තිබ්බ values වල function එකක් කියන එක තමයි මේ AR model එකෙන් කියන්නේ. එතකොට මුලින්ම අපි කරේ GDP කියන එක ගත්තම මෙන්න මේ GDP variable එක stationary වෙන්න කොහෙන්ද කියලා අපි බැලුවා. So in the second step, we have identified at which level the GDP becomes stationary. So we have identified that GDP becomes stationary at the first difference, not from the level data, right? Then we move to determine the appropriate AR model for GDP using the partial autocorrelation function. So අපි ඊළඟ පාර්ට් එක විදිහට කරේ මේ AR model එක ගත්තා. මෙන්න මේ GDP වලින් අපි run කරන්න යන AR model එක ගත්තා. මෙන්න මේ AR model එක ඇතුලේ AR item කීයක් තියෙනවද? එහෙම නැත්නම් අර කලින් අවුරුදු වල value වලින් මේ අවුරුද්දේ value එකට significant impact එකක් තියෙන factors කීයක් තියෙනවද කියලා අපි බලා ගන්න යනවා. මෙන්න මේක අපි බලන්නේ partial autocorrelation එක කියන එක පාවිච්චි කරලා. ඒතර මෙන්න මේ partial autocorrelation කියන එක ගත්තම මේකේ significance line දෙකක් තියෙනවා දෙපැත්තේ. මොකක් හරි භාගයක් මෙන්න මේ significant line එකෙන් එහා පැත්තට ගිහින් තියෙනවා නම් අපි identify කරගන්නවා ඒකෙන් significant impact එකක් තියෙනවා. එහෙම තියෙනවා කියන්නේ ඒක එක AR term එකක්. ඒතර ඒ වගේ AR term කිහිපයක් තියෙන්න පුළුවන්. එහෙම නැත්නම් එකක්වත් නැති වෙන්න පුළුවන්, එකක් තියෙන්නත් පුළුවන්. ඒතර මේ model එකේ අපි run කරපු එකේ තිබ්බේ එක AR variable එකයි. ඒකින් අපි කියනවා මේක AR1 variable එකක් කියලා. ඊට පස්සේ in the final step it is asked to estimate the AR model for GDP and interpret the results. ඒතර අපි final step එකේදී හන්නේ AR model එක estimate කරලා ඒකේ results ගැන කතා කරන්න කියලා. ඒතර අපි estimate කරේ මොකද්ද කිව්වොත් එහෙම DGDP. ඇයි අපි මෙතන DGDP කියන එක ගත්තේ කිව්වොත් එහෙම මොකද GDP කියන එක first level එකේදී නෙමෙයි stationary වෙන්නේ. ඒක stationary වෙන්නේ එයාගේ first difference එකේදී. ඒකින්ද තමයි අපි මෙතන DGDP ගත්තේ. ඊට පස්සේ අපි ගත්ත constant එක සහ AR එක. එතකොට මේකෙන් අදහස් වෙන්නේ මේ DGDP කියන එක. ඒ කියන්නේ මේ present year GDP value එක ගත්තම මෙන්න මේ present year GDP value එක හැදිලා තියෙන්නේ previous year GDP value එකෙන් කියන එක තමයි previous year GDP value එකේ function එකක් විදිහට තමයි මේක හැදිලා තියෙන්නේ කියන එක තමයි මෙතන අදහස් වෙන්නේ. එතකොට අපි ගිහින් බලුවොත් එහෙම මෙන්න මේ AR1 term එකේ coefficient එක තියෙනවා 0.51. ඒක ඒ වගේ මේක significant වෙනවා. මොකද T statistic එකට අදාළ probability value එක 0.05 වලට වඩා අඩු වගේක්. ඒකින්ද මේ AR1 term එක significant වෙනවා. හරිද? එතකොට so if we forecast what will be the present value is a 0.51. that means this coefficient into the previous year value plus the constant previous year value into this coefficient, that means previous year value into 0.51 plus this constant coefficient is the present year GDP, right? එතකොට මේ අවුරුදු GDP එක ගත්තම අපිට මේ අවුරුදු GDP එක හදා ගන්න ඕන නම් අපිට කරන්න තියෙන්නේ මෙන්න මේ constant එකට අපි එකතු කරනවා මෙන්න මේ AR term එකේ plus AR term එක into last year value එක. එතකොට අපිට හොයාගන්න පුළුවන් මේ අවුරුද්දේ value එක කීයද කියන එක. කිව්වේ මේ අවුරුදු GDP එක කීයක් වේද කියලා අපිට මේ විදිහට හොයාගන්න පුළුවන්. එතකොට ඒකත් එක්ක අපි අපේ ටියුටෝරියල් එකේ fourth question එක සම්පූර්ණයෙන්ම discuss කරලා ඉවරයි. The next question or the fifth question will be discussed in the second part of the tutorial 6. So there will be another recording for that. Thank you.